How can we predict the future using a simple straight line? It sounds almost too simple, but the idea is actually the foundation of machine learning. You may remember the equation y is equal to mx plus b from the school. In machine learning, it's the same idea, just different name. The slope becomes the weight, the intercept become bias, and x is our input data. The straight line is called a linear model. It represents the relationship between the input and the output. For example, as car weight increases, gas mileage usually decreases. The model tries to draw the best possible line through the data. But how do we know that if a line is good or bad? That's where the loss function come into the picture. Loss measures how far our prediction from the actual values. The bigger the distance, the bigger the mistake. A good model makes prediction that are close to the real data. The goal of training is to make this distance and the loss as small as possible. Think of it like a ball rolling down a hill. No matter where you drop the ball, it naturally rolls downhill until it reaches the lowest point, and that lowest point represents the minimum loss. Training a model works the same way. We start with random guess, we calculate how wrong it is, we figure out in which direction it reduces the error, we slightly adjust and repeat the process again and again. Over many iterations, the loss keeps decreasing. Eventually, the model settles down with the lowest point where the prediction are the best. One important thing is the learning rate. That we If the learning rate is too high, the model jumps around and may never settle down, and if it's too slow, the learning becomes very slow. So finding the best learning rate finds a balance study step towards the loss. So overall, machine learning is a simple loop. Start with a model, measure how wrong it is, adjust and reduce the error, and repeat the process in iteration. And the simple idea of reducing loss is actually the foundation behind everything from linear model to deep learning to the large language model.